Class.
Good afternoon, sir.
Today we'll be studying electrodynamics, physics 403, where we'll concentrate on derivation of derivation of electromagnetic wave equation with dielectric and in also a conducting media. Maxwell shows that a wave can propagate through a medium, isn't it?
Yes.
And we have seen from the four Maxwell equations. So today we'll see how to derive these wave equations and see the energy they carry and the momentum, which will form the bedrock of electrodynamics. So by the way, we have to write our Maxwell equations. So now we'll start with first the one in a dielectric medium. The Maxwell equations in a dielectric medium takes the following position. Sigma is known as current density. It turns to zero if it is dielectric. It is non-conducting. If it's not conducting, the current density is zero. I hope it's clear.
Yes, sir.
So now, the resulting Maxwell equations, rho, will turn also to zero. And we'll have our divergence of D as the first Maxwell equations goes to zero, which is Gauss's law. Divergence of B also turns to zero, second Maxwell equations. The third Maxwell equation says the coil of E is equal to minus B by T. And the fourth Maxwell equations, this thing is H is equal to the rho by dt. This is the E by dt. So now, please, there is something I want to bring to your attention, which is known as constitutive relations. In constitutive relations, B, which is known as electromagnetic field, is equal to mu and H, and D is equal to E capital E, which implies that my H is the same thing as 1 over permeability of mu, and my capital E is equal to D over E. So these are known as constitutive relations. It will also be applied to the derivation of electromagnetic wave equation in a dielectric medium. So when we want to derive this equation, please, the first method we'll take, the third and the fourth Maxwell equations, we'll pick the first one, we'll take its coil. If I take the coil of this equation, the third Maxwell equations, what I'll do here is the next thing is to eliminate the other field vector that is not E. What is the field vector here? B. Isn't it? Yes. If I put my constitutive relations B here, I will have H, electric field intensity. If H is here, I have to eliminate H by using this one here. And I will slot it back and I will get my wave equation in form of E. So let's see here, please. Wave equation. I told you the first thing, we'll take the coil of the Maxwell relations. That's the fourth Maxwell relations. That means the coil of E. You know the third Maxwell's law? All is clear. So please this will give me the coil. This is not minus. Please.
Mu
B
H
by T.
Yes, sir.
I hope it's clear.
Yes.
But my constitutive relation says here H, isn't it?
B is equal
B is equal to mu 0 H. So I'm removing B here. So I'll have my coil of E is equal to del into bracket minus mu the H by T. I hope it's clear.
Yes, sir.
Isn't it? So now, please, I will have my del cross the E is the same thing as minus mu d del cross of h over the t. Is there any ambiguity? I hope it's clear. I hope it's clear. So now we proceed and do our substitution. Isn't it? There is no problem. Let me know, please. So since we have this one here, you know that these relations, coil of E is the same thing as what? Coil divergence of E minus del square B. This is what the vector relationship of this here. But here, divergence of E is 0. So it implies that the left hand side is nothing but divergence of E, which is equal to minus mu d cross over t. I hope it's clear.
Yes,
So I told you after substituting, isn't it? For E, I will eliminate H. How will I eliminate H? I will bring a field vector that is the same thing with this E from the Maxwell equations. So that means I'm taking Maxwell first one. So instead of del plus H here, I'll put what? The one that has E. So see what happens here. I'm bringing minus del square E is equal to minus mu d by dt. This is del cross H is given by E dv over dt.
Yes,
So
sir.
that I will have my E,
Del E.
isn't it?
Yes, sir.
The E over the T. So we have my del square E is equal to, this one is a constant to come out, minus mu E d squared E by the T squared. So if I rearrange, I'll have my del square E minus mu not E d squared E by the T squared. So this is our wave equation in terms of